Hello, my name is Keshwani. That's K-E-S-H-W-A-N-I, Keshwani. I have been solving math problem for GMAT out of this book here, the GMAT Review, the official guide. If you do not own this book already, it's important that you buy one immediately. You will find it at mba.com. The problem that I'm about to solve is the one that you will find on page number 176, problem solving. Problem number 176. Let's take a look at it. It says the rectangular box is 10 inches wide, 10 inches long, and 5 inches high. Okay, so we're dealing with 3 dimensions here. What is the greatest possible straight line distance in inches between any 2 points on the box? Alright, so it's really helpful if we have the box in front of us. So I will do my best to draw a box. We'll see how it comes out. What is it? 10 by 10 by 5 is it? 10 by 10 by 5. Alright. So here we go, as best as I can. There we go. There is your box here, 10 by 10 by 5. This is 10 inches, this is 10 inches, and this is 5 inches. The question is, what is the greatest possible distance? Let me read it again, make sure I phrase it properly the way they do it. What is the greatest possible distance, straight line distance, between any 2 points on the box? Well, the greatest possible distance, had it been a 2-dimension picture, if it's just a 2-dimension picture of say 10 by 10, the answer is very simple. They're looking for the diagonal here. That's it. This is the greatest possible distance from here to here. This is 10, this is 10. Use the Pythagorean theorem and you find out that distance. But this is not a 2-dimension picture. It is a 3-dimension picture. And therefore the greatest possible distance is going to be this distance right here. From this, you have to picture it. You have to visualize in your mind. From this picture here, from this point here, to this point here. The question is, how are we going to find that distance? The answer is, very simply, we're going to first find this distance here, from here to here. Once I find this distance, let's give it a name instead of calling it this distance. I'm going to give this vertice's name. So first I'm going to find the distance from A to B. That distance from A to B is what I just showed you here. Except it's a square. I should have drawn it as a square. Let's draw it properly so it looks like a 10 by 10. This side is 10 and so is that. Let me redraw this thing here. This is 10. This is 10. The distance that I'm trying to figure out right now is this distance right here. Or that distance right here, makes no difference. If it makes it easier for you to see, let's leave it here so that we can use the Pythagorean theorem here. This distance that I'm trying to figure out is what I'm calling A to B here. This is your A to B. Once I find the A to B, once I have the distance A to B, I already know A to C, let's call it C here. We already know what A to C is, and this is a right angle. So again, we're going to use the Pythagorean theorem one more time and figure out C to B. That's all. Let's figure this out, A to B, which is very simple. Let's call it X here. So X squared equals 10 squared plus 10 squared, a simple application of the Pythagorean theorem, and I hope you know it. There are some basic things that you must know for the GMAT, and I don't have a liberty, I don't have a luxury of going into every little nitty-gritty details because I don't have the time in the videos. Of course, in the personal private tutoring, I go into as much in depth as I need to fulfill the requirement of the clients, depending on where you are, what's the caliber of the students. I help as much as what is needed here. But here I don't have the luxury because I have to keep my video clips under 10 minutes each time. Besides, I don't want to bore everybody to death because there might be many people who already know what the Pythagorean theorem is. So, I hope you know it. Excuse me. So, x squared would equal 200. And therefore, x, if you take the square root of both sides, would equal the square root of 200. So, I'm going to put that here, square root of 200. Now we're going to use Pythagorean theorem one more time. And I'm going to erase this thing and I'm going to draw this diagram, this dark triangle, ABC. We're done with this thing. Square root of 200 is there, A to B. I'm going to draw this triangle here. This is your A, this is your C. That distance is 5, A to C. A to B, I found out, is square root of 200, and I have to find out the distance B to C. Let's put them in the red ink again. This distance right here, B to C, is what I'm showing right here. And that's all it is. So we have to do the Pythagorean theorem one more time and solve for it. And once we have it, we're done. That's all it is. Having said that, it sounds like very simple, very straightforward, but if you don't know it, then of course it's trouble. Let's finish it up. So again, since I call x, the hypotenuse, I call it x before, I'm not going to call it x again, just to keep it separate. Let's call this, let's call it h for hypotenuse. So h squared will equal root 200 squared plus 5 squared, which is what the Pythagorean theorem is. Pythagorean theorem tells me that the square of the hypotenuse has to equal the sum of the squares of the two legs. This leg is root 200, I square it. This leg is 5, I square it, and the sum of the two squared would equal the square of the hypotenuse. So square of root 200 is simply 200, and square of 25 is 5. Square of 5 is 25, which is my h squared, and therefore h would be the square root of 225. And I hope that you know that 225 is a perfect square. There are some squares you should know by heart. 1 through 10, everybody should know it. 1 through 10, you must know it. 11 through 20, you have to know. I'm going to write down on the blackboard all the squares that you must know. I'm not going to write down 1 through 10 because I take it for granted that you know it. And if you don't know them, learn them by heart. 1 squared, 2 squared, 3 squared, so on and so forth. 1, 4, 9, 16, 25, 36, 49, 64, and 100. You should know that by heart. I'm going to write down the 11 through 20 that you should know. 121, 144, 169, 196, 225, which is your 15, 16 is 256, 17, 18, and 19 you don't need to know, and the last one is, you don't need to know 17, 18, and 19 because they don't appear very often. 20 squared is 400. You should know these by heart if you want to get a decent score on the GMAT, because you don't have a luxury of reaching for the calculator. So this is a perfect square, and square root of 225 is 15. And that's your answer, that's it. The answer is A. Let me take a quick look at the camera. That will tell me how much time I have to give you a pep talk, a sermon. I'm already 8 minutes into it, so I'm not going to go into detail anything and so forth, but I was trying to see here if there is anything that we can cross out as a nonsensical answer. 20 and 25, they don't make any sense to me. 20 is a classic sucker answer because what the people are thinking is that if you got a 10 by 10 by 20, therefore the largest possible distance is 10 plus 10 or 10 plus 10 plus 5. Those are silly answers. 25 represents the sum of the three sides. Cross it out. That's not possible. It cannot be as high as 20. It cannot be high as 25. Those are impossible answers. Answer has to be either A, D, or E. And of course we found out that it is in fact A, 15. I hope you found it helpful. If you wish to buy my DVDs in which I show you the solutions to all the math problems, or if you wish to hire me for personal private tutoring, in either case go to my website at www.prep.gmat.com. Send me an email and we'll talk. Alright? Thank you.